So this is about reflections, and I'm going to remind you there's two kinds. You can put it on the inside or the outside, or you can put it on both. So I'm going to just keep this one simple. It's going to be just a x squared minus 5. Would you agree this has been reflected? What did the reflecting? The negative. Where is it, on the inside or the outside? Outside. What kind of things happen on the outside? Nope. Yes. Yeah, vertical. Yes. Yes, it's vertical on the outside. Okay. I was thinking I was saying inside. Okay. So it's on the outside. Vertical on the outside. So those two changes are both vertical. Does the order matter? Yes. Yes, it does. All right. And we talked about that yesterday. So we'd start on the inside, but there's no changes on the inside. But on the outside, there's two. There's the first thing and then the second thing, and it matters. Would you please write down the two changes in order? And in a moment, you're going to check with the kid next to you and see if you had the right order. Use things like, do you remember the order of operations? And do you remember if you should trust it in this situation or not? Okay, talk to that kid next to you about what the two things are. Vertical reflect is first. And down 5 is second. Why? Is that because it's from left to right? No, that is not it at all. It's because this is a multiply, and multiplies come before subtract. And if you were on the inside, you'd figure out whatever you think the right order is, and then you'd reverse it. Everything on the inside is the opposite of what you would think. So let's try one of those. Let's say I had 2x minus 4, and I'm going to put this in a parenthesis, though, and that changes things. You know, as soon as I added that parentheses, that changes the order. Now, there's not even a reflection happening on this one, but there is two things happening. Does anybody remember what it's called when you multiply by something? Stretch. Very good. Okay. We'll talk more about those on a different day, but for right now, you just can call it a stretch. So there's two things. There's that and that. There's the first thing and there's the second thing, and make sure you do them in the right order, which is opposite of what you would expect. Okay, talk to the kid next to you. What do you think is first?
Stretch.
About half the kids are wrong.
4 and then stretch. Stretch and then not upwards. Okay. Left. No. One.
All right. Now, remember how the parentheses changed everything? Okay. Would you agree that in the whole PEMDAS thing, parentheses are the king of the hill? They're the first thing you're supposed to do, right? So then whatever's in the parentheses should be the last thing that you do. Okay, so you should have started with this. And I totally get the kid that's like, but that's a multiply and the other one's a subtract. Yeah, you're just ignoring the parentheses. Okay, the parentheses take priority, and so they should be first, but since we're on the inside, they're last. So this was a horizontal shrink. Now, I know nobody caught that because I had talked about it in terms of a stretch, but remember, they're the opposite of what you would expect. Horizontal shrink. And then the other one is a right 4. Isn't it hard to remember everything when it's like opposite? It'd be like trying to say sentences except in reverse.
Wait, so why?
Reverse in sentences say. Oh, it's really hard.
Why is it reversed?
Why is everything reversed on the inside? Because it's counterintuitive. Everything in there does the opposite of what you would expect. Like, have you noticed that when it said like x plus 5, shouldn't that feel like it goes 5 to the right? It should feel like that, but it actually goes 5 to the left. Everything on the inside is the opposite of what you expect. And if you don't believe me, like if you're like, but I think it's going to go to the left. Well, or I think it's going to go to the right. Well, try it. You can use Desmos as a good graphing calculator, or use a graphing calculator. Graph this. You'll see it's a parabola that has been moved to the left. That is counterintuitive, isn't it? Feels like it should move to the right, but it actually moves to the left. All right, so everything on the inside, opposite of what you would expect, including the order you do it in. All right, so now this is mostly about reflections, and today has a lot of this stuff on it. They're going to give you this funny little shape, like a baseball cap. Okay, so here's my baseball cap. Now, what if I wanted to do a reflection of it? Well, isn't there 2 different ways you can do reflections? Yes. There's horizontal and there's vertical. And everybody please sketch this. Make yourself a little baseball cap. Do it with 2 different colors, so that the baseball cap is a different color than the X and Y axis. Otherwise, it'll kind of blend in. Okay. Now, let's call it f of x. That's our function. Does it pass the vertical line test? Yes, it does. So it's a function. The vertical line test, you run like a vertical line like this over it, and it never touches twice, so it's a function. Now, can it be flipped? Yes, 2 different ways. There's either I could put a negative here. Doesn't that make it pretty clear it's on the outside? As opposed to I could put one in here, which would make it an inside one. And then you got to know the difference. One of them's horizontal, one of them's vertical, and I've been saying high-vo for a long time to remind you, horizontal on the inside, vertical on the outside. All right, I think the easy one is the vertical one. So we're going to erase this one, and we're going to just do negative of f of x. Sketch it. You should know what happens to this thing. Do you know what a reflection is? In a moment, I'm going to ask you to show this reflected sketch to the kid next to you and see if you guys get the same thing as each other. If you don't know, maybe you can learn from them. All right, compare with the kid next to you. Some kids just did a horizontal one. I know because I looked. This is supposed to be a vertical one. Vertical means like this. Who had done it correctly? Raise your hand if you did. I got to get a feeling. Okay, good. Okay, that's the vertical kind. Now, I know some of you wrote it over here. Do you get that that is the horizontal kind? Because it's like the horizon. It went this way. Okay? All right. There's your reflections. Now, what if we had to be more accurate? Everybody get it back to just f of x. And we actually want this to be like test quality, like not just kind of where it is, exactly where it is. Well, that spot everybody can tell is 0, 0. I'm going to say that this spot right here is going to be at 2, 1. This spot right there, think about it, use symmetry, what would it have to be? Right here. 4, 0, very good. This spot right here, probably 8, maybe even, that looks like a really long bill on the hat. I'm going to go with 9, 0. All right. Why do those matter? Because on the test, you're going to eventually have to do stretches and make it like twice as tall. Don't do this right now. I'm just showing you an example. Do you get my baseball cap now is twice as tall in the green? Okay, so that'd be a vertical stretch. What if I wanted to make it a horizontal stretch? Well, then I might want to make it like twice as long of a baseball cap. See, twice as wide, I should say. That would be like a horizontal stretch. So if I wanted that, I would have to put a 1/2 on the inside. Isn't that counterintuitive? Seems like that would make it smaller on the inside. Actually makes it bigger. All right. So enough about that. Let's just stick back to our regular function here. And here's a typical test question. Would everybody graph and label f of negative x? On the same graph. Just put it on the same graph as the other one. But this time you have to label the key points. Except 0, 0. In my opinion, a kid should never have to label 0, 0 because it's, it's at the origin. So figure out which kind of a flip that is, and then flip it, and then be careful to label the points. That's that kind of flip. But that isn't just any random spot. It's exactly -2, +1. That spot is exactly -4, 0. And this spot would be exactly -9, 0. Okay, now let me show you what would have happened if you had an XY chart and you had all of these points on it, 2, 1, 4, 0, 9, 0, and then I wanted to do this to it. Now, I have to take all of my X's and make them the opposite. Now, there's no way to do the opposite of doing the opposite. Otherwise, I wouldn't actually make any changes and it wouldn't go anywhere. So, when you put a negative on the inside, it does make all of the numbers negative. See how all my X's became the opposite of what they were? They used to be 2, 4, and 9. Now they're -2, -4, and -9. Did you notice that the Y's didn't even change? Okay. The most complicated kind will do both kind of changes. Like where we might flip it and then also move it. Do you get the hat could also have been moved down 5? Okay, now don't do it. But if I had wanted to flip it and move it down 5, do you get I would have said that? That's how I would have said flip it and move it down 5. And would the order matter? Yes. The order matters. And I tell you to always start on the inside. And that would be the flip part. And then do the stuff on the outside, which would be the moving down 5 part. Okay. Let's get into page 2 of the notes. Write an equation for each transformation described below. All right, so we got to write an equation. Well, I've already got an equation. It says y equals x to the third. Yeah, that's a good start. But now you're going to do something to that. Reflect it over the y-axis. Ooh, which kind is that? It didn't say horizontal or vertical. I guess I'm going to have to think about it. I'm going to draw my picture. And if I'm going to go over the y-axis, I'm going to go over that axis. Do you know what kind of a flip makes you go over that axis? Horizontal or vertical? Horizontal. When they say over the y, it's over the horizontal. If you want to connect y with horizontal, horizontal. I know, it's a little crazy, but it works for me. And if you want to go over the x-axis, that would have been a vertical. And x and vertical, you could think vertical. Or you could just draw yourself a little picture and go, okay, I guess it's going horizontal. So then I need a negative, and that's a really common mistake for a kid to put a negative right there. You may have meant to put it on the inside, but that's on the outside. How do I force it to be on the inside? With parentheses. Okay, there's my reflection over the y-axis, which is a horizontal one. And then up 5, oh, that's plus 5. Oh, and left 3, oh, this is important. Left 3, plus 3. Now I gotta think about whether or not I need to have a parentheses around this. I don't think at your level we have to worry about whether there's a parenthesis in there or not. What I was thinking is, should I have to put a parenthesis here? I don't. I don't think it'll matter because, do you remember the deal where if there's a negative inside here or outside here, either way, it's gonna act the same? Then I don't think it matters if we have a parenthesis on this one. Okay, there we go. That's an equation that does all 3 things they said. Reflects it over the y, that's horizontal, there it is. Up 5, there it is. Left 3, there it is. Now, if they had said in that order, then I'd have to double check it, but they did not say it had to be in that order. All right, try this one without my help. Write me an equation like that. Give it a shot. I know some of you are drifting, and I understand. It's not the most exciting thing on the planet, but if you can stay with me for another 10 minutes or so, we'll be done. You'll be working on your homework. Time to zone out then. You should have had y equals square root of x. And then you should have made 1, 2, 3 changes to it. Talk to the kid next to you, see if you got the same thing as them.
I got
Wait a minute, I didn't do my.
Wait, you can have one lecture. What you think?
Y equals negative parentheses negative x.
Is it something like this?
Parentheses plus 5.
Second. That's what. It's not a lot of calculation. That's what.
All right. Horizontal and vertical makes it easy because you don't have to even think about which one's which. Just need one of each. And then right 2. Okay, right 2. Seems like it should be plus 2. It's actually minus 2. All right, that makes sense? Okay, now tell me what order, the way I wrote it, what order would that have been in? You know the 3 things. Vertical and horizontal reflect.
Oh, wait a minute.
And right 2. What order would it have been in? Where do you start? Inside or outside? Inside. Of the 2 on the inside, can I trust the order that I think it should be? Do I trust it? No. So you figure out what order you think it should be, and then you do it in the opposite order. So this would be right 2. Horizontal, reflect. And then the last thing is on the outside. And that is vertical, reflect. Okay. Now, I want to warn you. Sometimes the keys are funky on this. Why? Because I keep telling you to start on the stuff on the inside. But technically, you can start on the inside or the outside. The only thing you really have to obey is that the stuff that is on the inside has to be in the opposite of normal order. That's the big rule. But you can start on the inside or the outside. What you can't do is jump around to anything you want. You can't like do some of the outside, then some of the inside, and then some of the outside again. You have to do all the outside stuff first or all the inside stuff first. And I'm going to keep on telling you, because I think it makes the most sense to start on the inside. But if the key starts on the outside, you have to understand that that teacher could start on the outside if they wanted to. It's legal. All right. Ooh. So, if they give you the equation, could you describe the transformations? Yeah. It's a parabola. Let's just call it a para. A parabola that has been, well, start on the inside. Ooh, it's at 2 plus x. Isn't that the exact same thing as x plus 2? Yeah. So then that's left or right? Left, 2. And then you go to the outside, where it would be vertical reflect and up 5. How come you did it in that order? Because it's order of operations. A multiply by -1 in the front comes before an add by 5. And you trust the normal order of operations there. Now it says domain and range. I strongly recommend whenever you do a domain and range, you have a picture. So I bet I can make this picture in 10 seconds or less. It'd be a parabola, except I'd flip it, and I'd move it left 2 and up 5. Do you get that? That not take that long. Now I've got a parabola I can look at. In my domain, oh, it's easy. It's going left and right forever. So it'd be -infinity to infinity. The range would be how low to how high. It goes infinitely low, -infinity. Can't touch that. To the highest it would go. Now I got to think about how far up I moved it. I moved it up 5. It would go to 5 and it would touch it. See, I have to have that sketch in front of me or I couldn't do it. So if I were you, I would definitely make the sketch. Because even the math teacher can't really do those in his head. I mean, you'd be risking it without a sketch. All right, try this one in the corner, and if you get this, you've pretty much got today's lesson. Sketch it so that you can make the domain range. All right, description. Okay, he said to start on the inside. I guess I should start on the inside. So he said that you don't trust the inside. But well, there's only 2 kinds of negatives. There's either the horizontal on the inside or the vertical. This is a horizontal because it's on the inside. Horizontal, reflect. And that would be first. The second thing would be down 3. Guys get the same thing as me? Okay, good. Then, domain and range. Honestly, you want to make a picture. And then you go, this is a V shape. What would the horizontal reflect do? It wouldn't do anything. Do you get if you horizontal reflect this, it'll go right on top of the old one? And then down 3, that does something. There's my picture. Now if I'm doing my domain and range from that, the domain is left to right and it goes forever. I would accept this shortcut, which is kind of faster than writing -infinity to +infinity. I'll zoom in on it. It's a double bar with an R. That is an official math symbol that stands for all real numbers. So from now on, unless the problem says specifically, must use interval notation, then you'd have to write this. But unless it says that, I'd be fine with that, which is faster. The double bar R. It's good for you to learn a few of these. These are official math language. You actually don't Yeah, you see it often in college. A big R means all real numbers. Okay. So I'll start using that for my domains when they're infinity to infinity. The range on this is how low, which is 3, negative 3, to infinity, and I just made a mistake. Bracket. Very easy to make that mistake, wouldn't it? All right. So, feel like you understand this stuff? All right. The only thing that gets weird is if they give you a weird little picture like this. So what if I have a weird little picture like this? Well, this is the second most missed question on the test. In my opinion, the most missed is the order thing. And you just gotta be really paranoid about like opposite of what you think on the inside. Okay. This question, the most common mistake is it's just so many little parts to it. Okay, so they labeled a whole bunch of points. -10, -4, you see that's the left part of the M. And then -8, 4, and then -5, 0, and then, okay, so these are just the points from this original M. M for Minnetonka. Then, we do stuff to it, like that. Now, could you just flip this thing and move it down 4? Yes, but it would be actually very hard to do. Like imagine just the flipping part of getting all the dots in the exact right spot and then moving them all down 4. Do you get how that would be hard? To flip this thing and get all the dots to move exactly down 4? Hard. So here's what you do. See that negative there? There's only one way to make something negative. Like you can't do the opposite of making it negative. Okay, so we are going to make the opposite of all the x values. So I go up here and I just do opposite of this, opposite of this, opposite of this, opposite of that. And opposite of 0 is still 0. Get why I did that? All my x's had to become opposite. If that had been like a times 2, you wouldn't have times 2, you would have times by a half. Because, you know, everything's weird in there. Okay, how about this down 4? Which do you think that affects, the x's or the y's? The y's. And can you trust the stuff? Yes, so it seems like you subtract 4, and you do subtract 4. So now I'm going to subtract 4 from all of these. Minus 4 equals, -4 minus 4 is -8. I'm going to have to zoom in a little bit. And minus 4 from this is 0, and minus 4 from this is -4, and minus 4 from this is -8, and minus 4 from this. No, this one was 0, sorry. And this one's -8. Now guess what you get when you graph all of these points? You get your M that has been moved to the right place. Okay, so let's try it. Let's actually see. I predicted the M would kind of be here, except I never even moved it down. So let's see where it ends up. -10 is 10, comma, -8. Over 10, down 8. There's a dot way over there. That's probably this dot, except it's been flipped. No, it's actually this dot. Except it's been flipped across and then moved down. Okay, it's one of my dots. Doesn't even matter which one it is. And if I graph all the rest of the points, that's going to be +8, 0. Dot right there. And then we got 5, -4. And then we got 2, 0. And then we got 0, -8. And if I connect all my dots, that's how you do it. So you take the parent points, you do the right thing to them, and then you graph your results. And that feels like it's been flipped and moved down, and that's what it should feel like. You know, double check it by going, Now, don't just trust, like, oh, I guess it looks like an M. Just try to figure out, I expected my thing to flip and move down, and it did. Yay. Now, in my dream world, they would have put all the original on each of these, like, slides. They would have put the original M on all of them. They didn't. You don't have to, because all you have to do is graph the new points. You don't have to put the original one on there and the new one. You just have to put the new one on there. So on this one, let's not do it, but let's just talk about what would happen. Would you agree that this has a negative on it? That is reflecting it. Is that on the inside or the outside? Be careful. It's outside, because technically this 3 could go here. All right, so that's on the outside, and that 3 is also on the outside. So both of those are affecting the Y. So does the order matter? Yes. Do you get if you add something, add 3 to something and then make it the opposite? That's different than making it the opposite and then adding 3? Yeah, it makes a difference. So what should be first? Careful, you're on the outside. You trust the order, the normal order of operations. The negative is first, because it's like a multiply by -1. So you're going to take all your Y values, change them to the opposite, and then add 3. So you take these parent points, only mess with the Y's, and you change them to the opposite, and then add 3. And then when you graph it, your M will still be there, but it'll be flipped vertically, so it'll look more like a W, and it'll be moved up 3. That's how you can kind of check and see if it worked. It's like you graph your little points, and if you're like, dang, that does not look like a W, well, or an M, then maybe something went wrong. Maybe you did one of your points wrong. All right, final test on this. If you had to, you'd take your parent points, and what would you do to the X's? Talk to the kid next to you about what to do to all the X's.
You would,
Add 5 is correct. Because it's the opposite of what you would think, because it's on the inside. You don't subtract 5 from all your X's, you'd add 5 to all your X's. Good. And then, what would you do to the Y's? Well, how about this? What would you do first? Make it negative. Yep. You'd make it negative first, because you trust this order, and the multiply comes before the add, and so you would make all your Y's negative, and then you'd add 2 to them. And when you're done, you'd look at your M that you used to have, and you'd be like, well, it's been flipped, and it should be 5 to the right, and it should be up 2. And if your M doesn't look like that, then you know you did something wrong. All right, that was intense, but now you have a worksheet on that, and I want to give you a bunch of time, which I am. I'm giving you over a half an hour, and this would be really smart, where if you're like, I didn't get what you were saying about that last part, come up and I'll give you a one-on-one lesson on it. I am going to have you skip a couple, so please pull it up on your iPad. I'll make it smaller and more doable. Can you please show me? It looks like there it is. Let's do number 1, A, B, and C. Let's scroll down. Let's skip D and E, because they're kind of overkill. Then go to number 2. We're going to do A and B. And
wait a minute.
You're
Question?
that all. You're
Can you
going
move up?
Yeah.
Yes, now that you're there. You're skipping D and E on the first problem. Number 1, skip dogs and elephants. On number 2, I want you to skip C and D, cats and dogs. On number 3, just skip Frankenstein. That cuts it down to a reasonable size assignment. Just skip F on the last problem. So work on that, and if you don't get that last kind, please come up and let me show you. Once I show you one-on-one, if I go through one problem with you, you'll probably get it. Okay. And your test isn't for a while, but that's because you have a lot of stuff to learn yet. Like, we have to learn several new topics before the test ever happens. Yes. As long as that pass says yes. Yes.